Hello to all my viewers. This is Dr. Dhaval Maheta, and today we'll understand the concept of panel data. Panel data, sometimes referred to as a longitudinal data, is data that contains observations about different cross sections across the time. Examples of groups that make up the panel data series include countries, firms, individuals, or demographic groups. Let's understand the concept of cross sectional data. Observations of the subjects are obtained at the same point in time. Just see for Form 1, Form 2, Form 3, and the year is constant. And y is a dependent variable, x1 and x2 are the independent variables. So this is a cross-section data. Let's talk about the time series data. Observations are generated over the time. Just see the year. Again, y the dependent variable, x1 and x2 are the independent variable. Panel data is the combination of cross-sectional plus the time series data. It is also called the longitudinal data. So for Form 1, we are having a data from 2018, 19, 20. Similarly, for Firm 2, 18, 19, 20. Firm 3, 18, 19, and 20. Again, y is a dependent variable, x1 and x2 are the independent variables. Types of panel. Balanced panel. It means that the number of years for each firm are equal. So equal number of observations for each firm for the entire period. There can be the micro panel, in which the number of firms is more than the number of periods. In this example, we have three firms, one, two, three, and only 2 years. So this is a micro panel. We can also have a macro panel. Number of periods is more than the number of firms. In this example, we have two firms, one and two, but 3 years. So this is the macro panel. Dynamic panel data, it includes the lagged values of the dependent variable as a regressor. So we will consider yi minus 1, that is a lag of the dependent variable also in our equation, that is known as a dynamic panel data. The method for the estimation will be general method of moments will be used. Unbalanced panel. Number of observation is not the same for all subjects. In this example, firm 1 has 2 years, firm 2 has 3 years. So this is unbalanced panel. Advantages of panel data. Panel data can model both the common and individual behaviors of groups. Panel data contains more information, more variability, and more efficiency than the pure time series data or the cross-sectional data. Panel data can detect and measure statistical effects that pure time series or cross-sectional data cannot. Panel data can minimize estimations biases that may arise from aggregating groups into a single time series. Panel data heterogeneity. Panel data series modeling centers around the addressing the likely dependence across the data observations within the same group. In fact, the primary difference between the panel data models and the time series model is that the panel data models allow for the heterogeneity across the groups and introduce individual specific effects. The examples of the panel data. As an example, consider a panel data series which includes the gross domestic product data for a panel of 5 different countries: United States, France, Canada, Greece, and Australia. A worldwide economic recession is likely to impact all 5 countries and cause changes in the GDP across all 5 countries. An election in Australia is likely to impact the GDP of Australia but may not affect the other countries in the panel. A change in North America trade policy may only regionally impact the US and the Canada. A change in the euro exchange rate will most directly affect only France and Greece. These are all the examples of the panel data. Now let's understand why traditional regression cannot be used on the panel data. We'll start with the first concept, the normal OLS. As there are three forms, 1, 2, 3, we will estimate a time series model for each firm using OLS, which will result in three regression models. The equation is yt is equal to beta 0 plus beta 1 x1 t plus beta 2 x2 t plus epsilon t, which is an error term. Now, what is the problem which will occur? We will get the disparate pieces of information which we will not be able to comprehend on how x1 and x2 jointly affect the y. Serial correlation might be a problem because of the time dependent nature of y. Not a good idea to run this type of regression. Now let's proceed for the another type of regression, which is cross section regression. So when we run cross section regression on panel data, what can be a problem? Now for each year, estimate a cross section regression. This means we have a three cross section regression, one for each year. Equation is yi is equal to beta 0 plus beta 1 x1I plus beta 2 x2I plus the error term. Very limiting because for each year we have only three observations of each firm with which we have to estimate three parameters, beta 0, beta 1, beta 2 in this example. This approach will severely limit the degree of freedom required to get the meaningful estimates. Not a good approach. Third one, between group cross section regression. Now what we will do here, we will take the average of y, x1, x2, and we will take the average. That is, we'll work on the average. The equation is yi average equal to beta 1, the average of x1I plus beta 2, average of x2I plus the error term. Run cross section regression using the averages. The problem will be it erases the time dependent information due to averages. It limits the sample size. Not at all a good idea. Now let's talk about the panel data regression and the advantages of it. Allows more observations, more degree of freedom, and more cross sections informations. Incorporates changes within a firm as well as changes across the firm. Can study impact of firm specific attributes, that is location, management philosophy, customer orientation, and also can also include culture. It's a best approach. Why panel data? Since panel data relate to individuals, firms, states, countries, over the time, there is bound to be heterogeneity in these units. By combining time series of cross sections observations, panel data give more informative data, more variability, less collinearity among the variables, more degree of freedom, and more efficiency. Panel data can better detect and measure effects that simply cannot be observed in pure cross sections or pure time series data. For example, the effects of minimum wage laws on employment and earnings can be better studied if we include the successive waves. Panel data enables us to study more complicated behavior models. For example, phenomena such as economics of scales and technological change can be better handled by panel data than by pure cross section or pure time series data. By making data available for several thousand units, panel data can minimize the bias that may result if we aggregate individuals or firms into the broad categories. So this was the concept of panel data. For more videos on econometrics using R, kindly subscribe to my channel. You can also refer my playlist in which I have uploaded videos on data science, machine learning, and artificial intelligence. Please don't forget to like and share my videos. You can also follow me on different social medias, link given in the description box.